Welcome to Educator.com. In today's lesson, we'll be covering functions, and we're going to discuss the definition of functions, some terminology related to functions, and also graphs and functions. First, the definition. A function is a relation in which no two ordered pairs have the same first element. Previously, we defined relation, and relation is a broader term. So first, just to remind you the definition of a relation, and to give you an example of a relation in table form. A relation is a situation where there are two sets of values that have a correspondence to each other. Members of the first set have a correspondence to members or a relationship with members of the second set. For example, this table describes a relation, and each member of the first set of the x values corresponds to a member of the second set. You'll notice something here though. In this relation, there are two number twos. So if I wrote this out as ordered pairs, if I wrote this relation out as -1, 2, 1, 3, 2, 4, and 2, 3, I'd have two ordered pairs that share the same first value. That is still a relation, but it is not a function. It violates this definition of a function, and because a function is a relation in which no two ordered pairs have the same first element, and these two have the same first element. So this is a relation, but it is not a function. It is not a function. Giving an example of a function. A function, on the other hand, would be something like this. -1, 1, 1, 1, 2, 3, 4, 5. This is a function. It's also a relation. So it is a relation, but it also meets the definition of a function. And if you look at the first terms, they're unique. -1, 1, 2, 4. If I were to write these as ordered pairs, each ordered pair would have a different x value. Now, they may have the same y values. The first two ordered pairs, -1, 1, and the second ordered pair, 1, 1, do have the same second value, but it's still a function. They just cannot share the same first value. Now we're going to talk about ways to ensure that what you have is actually a function. And you can do that by performing the vertical line test. This is a visual way of assessing whether or not a relation is a function. A relation is a function if no vertical line intersects its graph at more than one point. Otherwise, the relation is not a function. To understand this, let's look at this curve. And we'll assign some values. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Now, if this says a relation is a function if no vertical line intersects its graph at more than one point. Can I find somewhere on here where a vertical line would intersect at more than one point? Yes, I can. If I drew a vertical line, actually at various places here, I can see that the vertical lines intersect the graph at more than one point. So right here I have an x value of approximately 3.5. And then I'm looking, and my y value is about 1. Up here, I have the same x value, 3.5, and then I have a y value of about 2.5. So I look at this third point, and I have an x value again of about 3.5 and a y value of 5. So all these three ordered pairs share the same x value. And the reason that this vertical line test works is because coordinate pairs or ordered pairs that share the same x are going to be located directly above or below each other on the coordinate plane. So if points share the same x value of, say, 2, they are going to lie directly above or below each other. Now, let's look at another case where I have a graph, say, of this line. If I perform the vertical line test, no matter where I draw my vertical line, the line will only cross the graph at one point. Therefore, this line is the graph of a function because it passed the vertical line test. This curve is not a function. It did not pass the vertical line test. So again, the vertical line test is just a visual means of assessing whether or not you have a function. You graph out the relation and then see if you can draw a vertical line anywhere that will cross the curve at more than one place. Function notation. Sometimes, instead of seeing a function written as such, y equals 2x minus 7, so instead of using y, we sometimes use f of x, and this is how we say this, f of x. F of x equals 2x minus 7. And what this is saying is the function at x. So f of x can be either written this way for a function, or you can simply say y equals 2x minus 7. And the value that you get here is a function of x. In this notation, x is an element of the domain of the function, and f of x is an element of the range. Another thing you may see is a value assigned to x. So let's say that I'm going to let x equal 2. Then you may see it written like this, and this is f of 2. So this is going to be the value of the function, the value of y at 2, when x is 2. So in this situation, I'm going to substitute in 2 wherever I see an x, and that's going to give me 4 minus 7. So f of 2 is negative 3. Again, f of x is just equals 2x minus 7 is just another way of writing y equals 2x minus 7. And we can do that for specific values of x, such as f of 2. The first example asks me to determine if this relation is a function. And remember that the definition of a function is a relation in which no two ordered pairs have the same first element. So a function is a relation in which no two ordered pairs have the same first element. Okay, looking here, I could write out the domain, separate that out, so that I can really see if I have shared first values. I have 0, minus 1, 3, 4, 2, and minus 1. And what I see here is that minus 1 is represented twice. So these two ordered pairs, here and here, share the same first value. Therefore, this is not a function. It is a relation, but this is not a function. So my answer to is a relation a function is no. Example 2. Is y equals 3x plus 7 a function? Well, one way to approach this is using the vertical line test. But in order to do that, I need to be able to graph this function. So what I'm going to do is assign some values for x, determine what y is, and generate some ordered pairs. So if x is -2 and I plugged it into this equation, I would get -2 times 3 is 6 plus 7, so I would get y equals 1. And if I did that for multiple values, I would actually come up with a table that gives me some ordered pairs: -2, 1, -1, 4, 0, 7, and 1, 10. Okay, now that I have these ordered pairs, I can graph this relation, which is also possibly a function, and then I can use the vertical line test. So my first point is -2, 1. My second point is -1, 4. My third point is 0, 7. It's going to be about up here. And then my third point is 1, 10, which is going to be way up. So if I were to connect these, then what I would see, actually don't quite have room for that. So just working with these 3 points, since that fourth point would actually be off the screen, working with these 3 points, that's enough to draw a line. And what I see is that no matter where I draw a vertical line, it only crosses the graph at one point. So no matter where I draw a vertical line, it only crosses at one point. Therefore, this describes an equation where each element of the first set is unique. There's not going to be 2 ordered pairs that have the same first element or the same x value. So this passes the vertical line test, and this is a function. Yes, this is a function. In example 3, let f of x equal -3x plus 10, find f of 4 and f of 6 plus 7. Starting with f of 4, if I'm given f of x equals -3x plus 10, then for f of 4, I'm going to replace the x with the value 4. So f of 4 equals -3 times 4 plus 10. So f of 4 equals -12 plus 10. So f of 4 equals -2. So f of 4 equals -2. The second one is a little bit more complicated. This is asking me to find f of 6 plus 7. First, I need to find f of 6. So rewriting my function as f of x equals -3x plus 10. I'm going to find f of 6. Once I find that value, I will add 7 to it. So f of 6 equals -3. In place of x, I'm writing 6 plus 10. So f of 6 equals -18 plus 10. F of 6 equals -8. But what I was asked to find is f of 6 plus 7. So in lieu of f of 6, I'm going to substitute in -8, and I'm going to add 7 to that, and I'm going to get -1. So f of 6 plus 7 equals -1. So for this first section here, I was asked to find f of 4, and I did that by substituting in 4 for x in this equation. And I got a result of -2. The second one was more complex. I had to find f of 6, and then I had to add 7 to that. So initially, I substituted in 6 for the x in the equation, and I got a result that f of 6 equals -8. I went back and replaced f of 6 with -8, and then added 7 to that So I got f of 6 plus 7 equals -1. In this example, you see that they say g of x instead of f of x. It's a different letter, but you just handle it the same way. So let g of x equal -2x squared plus 4x minus 7. And we're being asked to find this whole thing. 3g to the -1 plus 5 times g of 2. So 3g of -1 plus 5g of 2. Okay. The first thing I need to do is figure out what g of -1 is and what g of 2 is. So starting with g of -1. G of -1, looking up back at my original equation, I'm going to substitute in a -1 wherever I see an x. So g of -1 equals -2, and then if I square -1, my result is going to be a 1 plus 4 times -1 minus 7. In the next step, I multiply, so -2 times 1, that's -2, plus 4 times -1, that's going to give me -4 minus 7. Now I'm going to combine all of these. -2 minus 4 minus 7 is -13. Okay, first step, I found g of -1, and that is -13. Next, in order to find this expression, I need to determine what g of 2 is. So I'm going to go back and do the same thing. I'm going to substitute in this value for x. Therefore, g of 2 is -2 times 2 squared plus 4 times 2 minus 7. So g of 2 equals -2 times 4 plus 4 times 2 minus 7. Next step, using order of operations, is to take care of the multiplication. -2 times 4 is -8 plus 8 minus 7. So g of 2 equals, well, -8 plus 8 is 0, so that just leaves me with a -7. Okay, I'm getting to the end. So I have g of 1 and I have g of 2. So I'm going to go back to this expression that I'm being asked about to find, and it's 3g of -1 plus 5g of 2. Now I can substitute in for g of -1, I'm going to substitute in -13. So it's 3 times -13 plus 5 times g of 2, which is -7. And what this equals is 3 times -13 is -39, plus 5 times -7 is -35, and that comes down to, when you put it all together, minus 74. So that is the final answer. So looking back up here, the way we handle this is to first find what g of -1 is and what g of 2 is. So I did that by substituting in -1 over here and then solving to find that g of -1 is -13. Over here, I substituted in 2, and g of 2 turned out to be -7. Once I had those two in place, all I had to do was substitute those values into this expression. So 3g of -1 plus 5g of 2. It gives me 3 times -13 plus 5 times -7. Solving that, I came up with -74. So today we learned about functions, how to define them, how to use a vertical line test to determine if a relation is a function, and we also discussed some notations relating to function. I'll see you next time on Educator.com.